Good morning, dear students. How are you? I hope all of you and your families are fine. Today, it is going to start physics class. All of you welcome to my class. I introduce new chapter. The chapter is units and measurement. For today class, I would like to present mainly two topics. First one, the international system of units, and second one, measurement of length. Part A. In physics, a very important term is always heard, which is physical quantity. What is a physical quantity? It is the quantity which is measurable. For example, distance, speed, acceleration, time, mass, force, etc. These all are the physical quantities. For measuring and expressing a physical quantity, we need unit. Then, what is unit? Unit is nothing. It is a standard quantity used to express the magnitude of a physical quantity. So we can say that measurement of any physical quantities means just comparison on with its standard quantity. Before I told, this basic or standard physical quantity is called unit. The result of measurement of a physical quantity is expressed by a number, that is numerical measure, which is accompanied by a unit. For example, when I ask any one of you, what is your height? He or she may say that my height is 72 centimeter. Here height is the physical quantity and centimeter is its unit. And you may have doubt, what should be 72? 72 is a number. So, it can say that this physical quantity is 72 times more than its standard quantity. Here we compare it with its unit. So, magnitude of a physical quantity is equal to numerical measure into its unit. You have to remember that physical quantity is divided into two types. First one is fundamental physical quantity. Second one is derived physical quantities. What are fundamental physical quantities? By its name, you understand the fundamental physical quantities are basic quantities which can be used to derive or form other physical quantities. Generally, there are three fundamental physical quantities. They are length, mass, and time. But in SI system, it is International System of Units. There are four more fundamental physical quantities defined in addition to this. That is, 7 fundamental physical quantities are there. The other 4 are electric current, temperature, amount of substance, and luminous intensity. Second physical quantity is derived physical quantity. What are they? They are deduced physical quantities from fundamental physical quantities. That is, they are formed from fundamental physical quantities. They are combination of fundamental physical quantities. For example, volume of cuboid, which is equal to length into breadth into height. Here, length, breadth and height can be considered as first fundamental physical quantity. So, volume is a derived physical quantity. You can find more examples of derived physical quantities. The units used to express the fundamental physical quantities are called fundamental units or base units. The number of derived physical quantities appears to be very large, but we have only limited fundamental units. But we need only this limited number of units for expressing all the physical quantities as they are interrelated with another. So, the units used to express these derived physical quantities are the combination of the fundamental units. These units, which are obtained for the derived quantities, are called derived units. A complete set of these units, both the fundamental units and derived units, is known as the system of units. Now, I ask you the questions, what are the different kinds of physical quantities? There are two types of physical quantities, fundamental and derived physical quantities. What is the system of units? It is a complete set of both the fundamental units and derived units. Now I am going to discuss on this topic the international system of units. In earlier time, scientific communities were using three different systems of units for measurement. They are the CGS, the FPS and the MGS systems. The base units for length, mass and time in the systems are, in CGS system, they are centimeter, gram and second respectively. In FPS system, they are foot, pound and second respectively, and in MGS system, they are meter, kilogram and second respectively. In all system of units, time has common units, it is second. The system of units which is internationally accepted for measurement is the SI system or International System of Units, which was developed and recommended by General Conference on Weights and Measures in 1971. For what purpose it was developed? It was developed for international usage in scientific, technical, industrial and commercial work. In this slide, a table of list of 7 base quantities, their SI units and their symbols is given. First base quantity is length, its unit is meter and symbol is small letter m. Second one is mass, its unit is kilogram and symbol is kg. Third one is time, its unit is second and its symbol is small letter s. Fourth one is electric current, its unit is ampere and its symbol is capital letter A. Fifth one is thermodynamic temperature, its unit is Kelvin and its symbol is capital letter K. Sixth one is amount of substance, its unit is mole and symbol is MOL. And last one is luminous intensity, its unit is candela and its symbol is CD. In addition to these 7 fundamental physical quantities, there are 2 more fundamental quantities and their units which can be defined in SI system. These 2 fundamental quantities are plane angle and solid angle. Next part, let me discuss on these quantities and their units. First one is plane angle. Consider a part of a circle as shown in the first figure. Let small letter r be the radius of the circle and ds be the length of the arc. Then plane angle is defined as the ratio of the length of the arc ds to the radius r. Plane angle is represented by d theta. Mathematically, it can be written as d theta is equal to ds divided by r. What is its SI unit? Its SI unit is radian and its symbol is RAD. Second one is solid angle. What is solid angle? Consider a part of a sphere as shown in the figure 2. Let dA be the intercepted area of the spherical surface described about the apex O as the center. Let small letter r be the radius of the sphere. How can define solid angle? It is defined as the ratio of the intercepted area dA to the square of radius of the circle. Solid angle is represented by d omega. Mathematically, it can be written as d omega is equal to dA divided by r square. Its SI unit is steradian and its symbol is SR. These two physical quantities, plane angle and solid angle, are dimensionless quantities. What is dimension of a physical quantity? Whose detailed study will be in following class. This slide shows a table consisted of some units written for general use. They are known SI units. There are 3 columns given in this table. First one, name, second one, symbol, and third one, value in SI unit. First, minute, symbol, MIN, and value in SI unit is 60 seconds. Second one is hour, symbol is H, and value in SI unit is 60 minutes is equal to 3600 seconds. Third one is day, symbol is D, and value in SI unit is 24 hours is equal to 86,400 seconds. Fourth one is year, symbol is Y, and value in SI unit is 365.25 days is equal to 3.156 into 10 the power of 7 seconds. Fifth one is degree, symbol is given degree, and value in SI unit is 1 degree is equal to pi by 180 radian. Sixth one is liter, symbol is given capital letter L, and value in SI unit is 1 decicubic meter is equal to 10 the power of minus 3 meter cube. Seventh one is ton, symbol is T, and value in SI unit is 10 the power of 3 kilogram. Eighth one is carat, symbol is C, and value in SI unit is 200 milligram. Ninth one is bar, symbol is BAR, and value in SI unit is 0.1 million Pascal is equal to 10 the power of 5 Pascal. Tenth one is Curie, symbol is CI, and value in SI unit is 3.7 into 10 the power of 10 second raised to minus 1. 11th one is Roentgen, symbol is capital letter R, and value in SI unit is 2.58 into 10 the power of minus 4 coulomb per kilogram. 12th one is Quintal, symbol is Q, and value in SI unit is 100 kilogram. 13th one is Bahn, symbol is B, and value in SI unit is 100 Fermi meter square is equal to 10 the power of minus 28 meter square. 14th one is Acre, symbol is A, and value in SI unit is 1 deca meter square is equal to 10 the power of 2 meter square. 15th one is hectare, symbol is HA, and value in SI unit is equal to 10 the power of 4 meter square. And 16th one is standard atmospheric pressure, symbol is ATM, and value in SI unit is 1,01,325 Pascal is equal to 1.013 into 10 the power of 5 pascals. Next topic is measurement of length. For common measurement of length, we have used meter scale. You know that all measuring devices have least count. What do you mean by least count? Least count of an instrument is the smallest measurement which can be made accurately with the help of it. The meter scale has least count. It will be 1 millimeter. That means the smallest measurement made by it is 1 millimeter. In it, there is smallest division made with value of 1 millimeter. Length can be measured using meter scale. Range is given 10 the power of minus 3 meter to 10 the power of 2 meter. That is, it may use up to the measurement of 10 the power of 2 meters. Vernier calipers with least count 10 the power of minus 4 meter and screw gauge and spirometer with the least counts 10 the power of minus 5 meter each. To measure length beyond these ranges, we make use of some special indirect methods. This slide gives range and order of length of objects. It will be helpful for you to understand the sizes of objects or their distances and compare their sizes or the distances with one another. You know, it is impracticable to use the physical devices we have to measure the large distances such as the distance of a planet or a star from the Earth. For this purpose, we have to use one important technique or method which is called parallax method. What do you mean by parallax? For understanding it now, I give one example for you. Suppose you stand near B, a white wall. You mark a dark dot on the white wall in horizontal line of your sight. You hold a pencil in front of you against the dark dot on the wall, which is a specific or reference point on the background. And look at the pencil first through your left eye, A, closing the right eye, and then look at the pencil through your right eye, B, closing the left eye. What would you notice? You notice that the position of the pencil seems to change with respect to the reference point on the wall. This is called parallax. Then you have to understand about its basis. The distance between these 2 points of observation is called the basis. In this example, the basis is the distance between the eyes. Now I define parallax. Parallax is a displacement or difference in the apparent position of an object viewed along two different lines of sight and is measured by angle or semi-angle of inclination between those two lines. Distance between these two viewpoints is called basis. Next, I am going to discuss on how can measure distance of a planet using the parallax method. Let us consider a planet which is at position S as shown in the figure. To measure the distance d of this far away planet S by the parallax method, we observe it from two different positions which are called observatories A and B on the Earth, separated by the distance AB is equal to small letter b at the same time as shown in the figure. We measure the angle between the two directions along which the planet is viewed at these 2 points. The angle ASB is represented by symbol theta. which is called the parallax angle or parallactic angle. As the planet is very far away, b divided by capital letter D, which is very less than 1, and therefore theta is very small. Then we approximately take AB as an arc of length b of a circle with the center at S and the distance d as the radius. AS is equal to BS, so that AB is equal to small letter b is equal to d theta, where theta is in radians. So we will get an equation d is equal to small letter b divided by theta, which is the equation number 1. Like us, we have determined the large distance capital letter D, that is the distance of the planet from the Earth. We can use the similar method to find the size or angular diameter of the planet. Let small letter d be the diameter of the planet and alpha be the angular size. What is the angular size of the planet? It is the angle subtended by the diameter of this planet at the Earth. Then we have to modify the equation 1, which becomes as capital letter D is equal to small letter d divided by alpha. Then alpha is equal to small letter d divided by small letter b, which is the equation number 2. Where alpha be the angular size of the planet and small letter d be the diameter of the planet. It is seen that alpha is angle between the directions of the telescope when two diametrically opposite points of the planet are viewed. The angle alpha can be measured from the same location on the Earth. Since the distance of the planet from the Earth, capital letter D is known, the diameter of the planet, small letter d, can be determined using the equation 2. Dear students, I will give you some homework questions after my class. You have to work out these questions by that day itself. For your reference study, I promote a book written by S.L. Arora, which is better for the reference and helpful for you. Today's homework questions are given in this slide. Okay, thank you. Have a nice day.